Bismillahirrahmanirrahim. Hello everybody. This is an exercise about Cauchy sequences technique. So let UN be a real sequence and define Vn, a sequence such that its nth term is defined by Vn equal to the sum from k equal 0 to n, the absolute value between un plus 1 and un. If we suppose that Vn is bounded, show that Vn is convergent and un is also convergent. So the first question, if we suppose that Vn is bounded, how we can show that Vn is convergent? Vn is bounded. We can remark easily that Vn plus 1 minus Vn is equal to the sum from k equal to 0 until n plus 1, the difference between you index can and you index can, minus the sum from k equal 0 to n, the difference between u index k plus 1 minus u index k, and this is equal to the absolute value. So from k to n, what we will keep? We will keep k from n plus 1 just, so we have un plus 2 minus un plus 1, which is greater than or equal to 0. This means that Vn is non-decreasing and bounded, so upper bounded. Using monotonic theorem, we deduce that Vn is convergent. How about un? Actually, we have many theorems and corollary about convergent sequences, but here we can remark that un is Cauchy. We try to prove that un is Cauchy sequences, and as we are in a complete space, so all Cauchy sequences are convergent. Let be n and m from n, and consider the difference un minus un, and consider this. Can we prove that this is less than or equal of something? What we can do actually, we can write the difference un minus un. This is equal to, we can suppose without loss of generality that n is strictly greater than m. This is equal to un minus 1 plus un plus un minus 1 plus minus un minus 2 plus un minus 2, and so until un plus 1 minus un. Using delta triangle inequality, if we use the triangle inequality, we can find that this is less than or equal to un minus 1 plus un minus 1 minus un minus 2 until we arrive to un index n plus 1 minus u index n. And this is actually, this is the sum from k equal to 0 until n plus 1 until n minus 1 to uk plus 1 minus uk. So we start from k equals 0 to n minus 1, so we keep this one, minus the sum from k equal 0 until m minus 1 of uk plus 1 minus uk. This is actually, this is v index n minus 1, and this is v index n minus 1, less than or equal. And since n minus 1 is greater than n minus 1, and since vn is a no decreasing sequence, we can take absolute value. And here we can conclude. Why we can conclude? We can conclude that un is, so un is Cauchy because Vn is convergent, and since it is convergent, this means that in this case, because we are in R and R is a complete space, this means that Vn is Cauchy pi. Vn is Cauchy. This means that un is Cauchy, and since it is Cauchy, so it is convergent. We can actually say that for all epsilon greater than 0, we can find an epsilon from n, such that for all n minus 1 greater than n of epsilon, n minus 1 and n minus 1 greater than or equal to n of epsilon, this implies that for all n and n greater than n of epsilon minus 1 I am thinking about this n of epsilon is for n minus 1 and n minus 1. So if n minus 1 is greater than n of epsilon, so n is greater than plus 1. this will be this will be the n prime of epsilon, the integer part, such that this implies that un minus um is less than epsilon. So this n prime is this one, and n of epsilon is actually for v. This is for v. And this ends this exercise. Thank you very much. See you next time.